Hi everyone, I'm Carl Shepherd, the Data Jiu-Jitsu guy. Today, in this video, I'm going to talk to you about the metrics layer, which can also sometimes be referred to as semantic layer or metric stores. This video is aimed at anyone with an interest in data, and I'm going to aim to keep it as simple as possible. But knowledge of data lakehouses, data lakes and data warehouses would also be very, very beneficial. If you're not familiar with these topics, I also have a 4-part series that talks about these topics, which is called the Data Analytics Journey, which you'll be able to find on my channel. So if you're not familiar with those topics, I'd recommend pausing this video and going through those first.
So the agenda for today, I'm going to take you through what a metrics layer actually is. And we'll spend quite a bit of time here because I think it's quite a complicated topic. I'll then take you through why you should actually use a metrics layer. I'll then take you through how this actually works and give you a very simple demo. And then finally, we'll have a quick summary. So first of all, what is a metrics layer? Now, I think a metric layer, if you Google it, it's not particularly well defined when you look at like the major vendors and things like that. So Microsoft, Amazon, people like that. But I found on this particular blog post by transform.co, I found a quite good description. So what they say is that a metrics layer is a centralized repository for key business metrics. This layer sits between an organization's data storage and compute layer and downstream tools where metric logic lives, like downstream business intelligence tools. A metric layer is a semantic layer where data teams can centrally define and store business metrics in code. It then becomes a source of truth and metric, which means people who analyze data in downstream tools will all be working with the same metric logic in their analysis. So I just wanted to show you where a metric layer actually sits before I get into going into too much detail of what one is. And this is the Data Lakehouse diagram, which I've shown in some of my previous videos. And a metrics layer would sit just outside of it here to the right of the gold layer. And the metric layer would consume data from the gold layer, and then it would pass on this information to the BI tools. It's got an ML on here as well, but generally I'd expect that metric layers at this moment in time only really serve BI tools, whereas ML you would generally go straight into gold. So what is a metrics layer? I think this diagram sums it up quite well, to be honest. Just ignore the bit where it says fat metrics layers for now. I will go into that in a little bit more detail in a couple of slides. So a metrics layer sits in the middle here, and what you do is you have a semantic model definition. So this is where you define all your metrics and all of your entity relationships. So this is usually in a star schema, so like all your facts and dimensions, which I've talked about previously, and then that all sits here. The data source will be most likely be your data lakehouse, which we've talked about previously, and that will the metrics layer will get its data from here, and then you've got your client tools, so your BI tools, your dashboarding tools, and things like that will issue requests against this metrics layer, and the metric layer will return the results back to the client. So metrics layers are semantic layers. It's not a new concept, and they have been around for a long time, and they've been used extensively for business intelligence when sitting them over data warehouses. There are great tools out there that allow you to create a metrics layer for BI or descriptive analytics. I don't personally believe that at this moment in time they are mature enough to handle both BI and ML. Another thing worth pointing out is that a metrics layer is actually not a prerequisite for creating BI or analytics, because you could just query the Lakehouse direct. But I would argue that creating trustworthy analytics is a real challenge without one, particularly at larger enterprises. There are a lot of organizations that use a metrics layer, but generally only with BI workloads, and they rely on feature stores for ML workloads, which aren't generally as flexible. There are also plenty of organizations that don't use a metrics layer and define metrics or KPIs within single BI products and dashboards. The issue with this approach is that it's difficult to maintain consistency, particularly challenging when you've got larger data teams. So I'm now going to go into the thin versus fat metrics layers. So I'm going to start with fat metrics layers, and just worth pointing out as well is that this image was taken from a blog post that was done by Arimas Rakas, which is really good and definitely worth a read. So on the fat metrics layer side of things, as I mentioned, you've got your metrics layer. You define all of your KPIs and metrics and your entity relationships here. And what you do is you actually ingest the data from your data lakehouse into your metrics layer. And then the client tools, so the different BI tools and dashboards will actually request the information from this metrics layer, and the metrics layer will do all the computation and send the results back. So contrast that with the thin metrics layer. So all the middle bits exactly the same. You define your metrics layer, you define all your KPIs, your entity relationships and things like that. But what happens is that when the client issues a request to the metrics layer actually goes back to the data source itself, so the data lakehouse, and all of your computation happens here. And then the results get sent back to the metrics layer, who will then return it to the client. So as you can imagine, both very valid approaches, and both have advantages and disadvantages, which I'll talk a little bit about in the next slide. So fat layers let you define the metrics and relationships, but also have an engine database to compute them. Thin layers define the metrics and relationships, but then hand over computation to the data source, such as the data lakehouse. Fat layers will almost certainly give you better performance on BI dashboards due to the data being stored and optimized for this type of workload. But thin layers have the benefit that you don't need to store your data in more than one place. And just to give you some examples of the different metrics layer tools out there, you've got Power BI, ThoughtSpot, Tableau, and there's plenty more, but these are three of the main ones. And all three of these tools offer you both a fat layer and a thin layer approach. So I briefly talked about this earlier, but metric layers are generally best at serving BI workloads, and you don't often see them serving analytics and data science workloads. What I'd like to see in the future, and this is something that's been proposed by Ben Stanstill on his Substack, is that you have a metric layer which sits outside of your data lakehouse, like I talked about earlier, but that can serve all the different analytics use cases out there, so including data science and even potentially operational applications. So if you'd like to do a deep dive into metrics layers, I'd recommend the blog post by Aramis Raka that I mentioned earlier. There's also a really interesting customer success story on Microsoft about Walmart, who implemented a metric layer. That's a really good read. Ben Stanstill's Substack, which I've just mentioned, and then Chris Webb also does a post about semantic layers, or metric layers as they're more commonly known. So why would you actually want to use the metrics layer? So a metrics layer is a trusted source for analytics. The metrics layer can be tightly controlled with processes in place to ensure its accuracy and reliability. Without a metrics layer, it's very challenging to ensure that all of your organization's dashboards and reports use the correct metric definitions. It also becomes easier to create new BI solutions because once the metrics layer is defined, it can be reused multiple times and there isn't any duplicated effort. Also, metrics or KPIs are actually more complicated than just simple sums of columns, such as revenue. And you have other metrics that are non-additive, such as margin percentage. And I'll talk a little bit more about that in the demo later. And within the metrics layer, you create a semantic model which knows how the facts and dimensions relate to one another. If the business decides to change the definition of a metric, you only need to change it in one place, and this will propagate through to all the dashboards that use it. If you imagine a scenario where a business change the definition of a metric and they don't have a metrics layer, they need to find out all the different dashboards that are using that particular metric and ensure that it's updated in there. It also decreases the complexity for data analysts and data scientists, and you also get faster time to insight. I also thought this diagram, which I've taken from the customer success story I mentioned earlier for Walmart, I thought this diagram summed things up nicely. So you've got your centralization of data in the middle, which is your metric layer. And all the benefits around that. You've got reusability of the data, you've got speed to insight, there's no wasted time and no duplicated effort. It's also easily consumable, and the data automatically refreshes for you. So how does it work? And I'll give you a very simple demo of how this actually works. So as I mentioned earlier, we're going to talk about this mainly from a BI metrics layer point of view with the simple demo. Generally, a central team will build and maintain the metrics layer, and this is usually data engineers or analytics engineers. You've then got data analysts and business analysts who can connect to that metrics layer to create their solutions. One way to demonstrate how valuable a metric layer can be is with an example. So margin percentage, as I mentioned earlier, is an example of a non-additive measure, which means that you can't aggregate it. And therefore, you wouldn't be able to store the values for margin percentage in your lakehouse, and you would need to redefine this each time you use it without a metric layer. So I've included the definition of the gross margin percentage, which is relatively simple, but every time someone needs to use that particular, because you're not going to be able to store it in the lakehouse, every time someone needs to use that particular metric, they're going to need to know how to define it each time they use it, which is really open to error, and you could end up with different answers in your dashboards. So into the demo, I've just used simple screenshots for the demo rather than opening up Power BI itself, just to keep things simple. So what we've done is we've used Power BI to create this metric layer for the demo, and this would typically be done by a data engineer or analytics engineer. One thing to be aware of is that Power BI can act as both a metric layer and a dashboard tool that connects to the metric layer, so it's just worth highlighting that. So what we've done is we've used a simple example of an airline company with relationships defined in a star schema, and I've basically manually loaded some imaginary data. So as you can see here, we've got 3 tables, very straightforward. We've got fact flights in the middle, which gives you all of your flight information. And then we've got a customer dimension. It's just got some basic customer information. And then a type dimension, which is basically just the type of trip in terms of whether it's leisure or a business trip. The next step, once you've defined how those relationships work, is the data engineer can then define the appropriate metrics or KPIs. So these are different metrics that we've defined within our particular metrics layer. So we've got a very basic one here, which is just a sum of your sales amount column. We've then got the sum of the cost column. And then this one's a bit more interesting, and which is the margin. And that's going to be the sum of the sales amount minus the sum of the costs. So the first 2 that we put through here. And then finally, the more complicated and interesting one, which is the margin percentage. And that's going to divide the sum of the margin by the sum of the sales amount to give us the gross margin percentage. And once we've defined all this, the data engineer can then publish this metric layer so that it can be consumed for analytics. So the data analyst can connect to the metric layer and create dashboard, which for this demo, we've also done in Power BI. And I've just shown you this here. This is just, we've published this airline simple metric layer just to a database somewhere. So it acts as a metric layer, and that's how we've connected. And what you can see here at the bottom, we've pulled together some really simple visuals into tables. And what you can see is that the tables with margin percentage are working at all different levels. And without that metrics layer, you need to remember how that metric works every time you use it. So if you look here, we've got the margin percentage, which is working at the individual level, and it's also working at the total level, which is great. And you can also see very simply here, you've got the margin percentage per customer as well, which is also very useful. And just one thing to highlight as well is that this particular metric layer that you've created, that all the data analysts can then connect to this metric layer to produce dashboards without worrying about defining any of the metrics. So finally, to summarize, I'm really interested to see how this space evolves over the next few years. I hope from this video, you can see the benefits of building a metrics layer for your organization. I don't believe we are at a point where we can safely say that there is a metrics layer vendor that can currently serve all analytics use cases effectively. I believe that Power BI is currently the most sophisticated metrics layer tool, but it is better suited to BI workloads and isn't very well suited to ML at present. The thin versus fat discussion is also very interesting. I believe that thin makes the most sense longer term and is the best approach when combined with a data lakehouse, but I'd argue that currently the performance benefits of fat outweigh the benefits you get from going thin. However, you will likely still see a combination of approaches, such as composite models, which have elements of fat and thin. Another thing worth pointing out as well is that Databricks hasn't really got involved in this space, but I'd be really interested to see if they do at some point in the future, and possibly in collaboration with Microsoft, where Power BI could maybe enhance to the point where it can sit over the top of a data lakehouse and act as the metric layer for all analytical workloads. I also think that other vendors have a big part to play here as well, and I believe that there's a big opportunity to cause some major disruption within the data industry. Thank you very much for listening. If you've enjoyed this video, then please like and subscribe. And if you've got any questions or comments, then please leave them in the box below. Thank you very much.